We're going to look at angles. So there's a couple ways angles are measured. We have degrees, and then we have radians. So we can convert between the two. If we are wanting to go from radians into degrees, we would take the radian measure and multiply it by 180 degrees over pi. And if we wanted to go from degrees to radians, we would start out with the degree we have, and then we'd multiply it by pi over 180 degrees. And we would get what we would need. So let me do some examples for both of these. So let's say I had, we'll go from radians to degrees first. Let's say I had 2 pi over 3 radians, and I want it in degrees. So I would multiply by 180 degrees over pi. And then when we multiply fractions, we multiply straight across the top. So 2 times 180. And I'm going to leave pi in the answer because you're going to see something that's going to happen. So 360 pi over, and then 3 times pi. And then we're going to reduce the fraction. Pi is going to cancel out because it's in the numerator and the denominator. And then we'll take 360 and divide it by 3, and we get 120 degrees. And I'll go the other way and go from degrees into radians. So let's say I have 90 degrees. To get into radians, I will multiply by pi over 180. 90 is really 90 over 1, and then I can do the same thing. Multiply across the top, multiply across the bottom, and reduce. So this would be 90 pi over 180. And then I can reduce the 90 over 180 because that's just 1/2. So 1/2 pi. Or you might see it as pi over 2. Okay? We mainly work in degrees, so let's just focus on being in degrees. So we have a couple different types of angles. We have something called a straight angle, and that is a angle that measures 180 degrees. Makes a straight line. A right angle is a degree that measures 90 degrees. Usually it's denoted with a little square symbol. An acute angle, those are just angles that are under 90 degrees. And then obtuse angles are angles that are more than 90 degrees. Like, really, it's between 0 and 90, and this one's between 90 and 180. Right? We can name angles different ways. Because this is just one angle in this image, I could call that angle A using the vertex. But let's say it had multiple rays in the image. We would call the angles with 3 letters. So and then we have this little angle symbol. That's how I know it's an angle. I could go CAB, or I could go the other way and go BAC. As long as the vertex of the angle is in the middle of those 3 letters, then it's fine. Right, we could also say something like this, and that means measure of angle A. So if I put a number to it and said that this is 25 degrees, you could say the measure of angle A is 25 degrees. Right? So here's where we have a bunch of options here. All right. So we would label them with 3 letters since there's so many options here. So let's start with just some obtuse angles. So because it's on this grid the way that it is, this would be a right angle, this would be a right angle, kind of like that whole origin part of it. We have a vertical line and a horizontal line. They are perpendicular, so they form those right angles. Okay, so let's start with some obtuse. And I'll draw them and then I'll label them. So obtuse is greater than 90. So if I say that this is 90, something that's greater than it would be an angle like that. So angle, and I can say J-O-E. J-O-E. Another one could be with K. Angle K-O-E. All right. So that's just 2 examples. I think I'll just do 2 of each. All right, acute. So that's less than 90. So if I'm looking at my right angle here, I see 2 that are less. So one of them being F-O-E and the other being G-O-E. All right, a straight angle. These are the ones that are making straight lines. So I could say this horizontal line, L-O-E. Could also call the vertical line a straight one. There's only 2 letters here, but we could use those. H-O. And then some right angles. So that's the 2 straight lines. Those form those right angles. So I could use this one. E-O-H. I could also do the other one here and say angle L-O-H. That works as well. I don't have a point down here to be able to do these 2, so I could make a point up there. But I think having 2 examples of each is good enough. All right, I'm going to give you some more definitions here. We have different kinds of angles here. We have adjacent angles. So these are angles. Yeah, maybe I should put that. Angles that share a ray, or I call it a side. I'll just draw an example here. So if I have kind of, you know what, I could kind of draw, well, you know what, no, we'll use this. I saw my drawings on here. So I've got one angle here, and then I have another one here. Do you see how they share? Oh, I wish I had a purple, because red and blue makes purple. They share this line segment OK here. They are adjacent angles because they are sharing that side or that ray. All right, vertical angles. This will show up on the next page too, but angles that are across from each other. And then a fun fact about them, they are congruent. That's the symbol for congruent, meaning they are the same measure. So if I draw 2 lines here, this angle here and this angle here are vertical angles because they are across from each other. These supplementary angles, these are angles that add to be 180 degrees. So I could make a straight line, if I can draw straight. And I could draw two angles. I could say the one on the left, I could say that that one is 80 degrees. And the other one, because it's supplementary, it adds to be 180. So I'd have to have that being 100. Complementary angles that add to 90 degrees. So if I have a right angle here, and I just draw an extra ray here, this measure could be 30 degrees, and that would make this one have to be 60 degrees because they are complementary. Now here's some others, or other types of angles and different relationships they have. So I will just draw visually what these angles are, and then on the right side, they're either going to be congruent, meaning they're the same measure, or they're going to be supplementary. So corresponding angles. If I say, let me define a transversal line. So it's a line that intersects two or more parallel lines. So in all of these cases, these two lines are parallel. It's the symbol for parallel. And then we have a line that intersects both of them. So corresponding, if I use this angle here, corresponding means that if I were to take this line here and move it just on top of this one here, where would this angle now be? So if I move that top line, just shifting it down on top of the other one, it would be right here. I can do another one and say that this is angle 2. If I do the same thing and shift that line down, it's going to go here. Now, we don't have to shift the line down. I could start down here, and I could shift the line up. It's still going to be here. And I'll fill out that last one here and here. So corresponding angles, if I'm, shifting this line up and down on top of the other line, and it goes right on top of that other angle, they're going to be the same measure. So angles are congruent. And I'm going to, I'm just going to write the symbol for congruent on the rest of these that are congruent. Our vertical angles, we already kind of talked about those. They're across from each other. So if this is the first angle, that's the one that's vertical to it. These two are vertical. And I could do the same thing in the bottom line. So vertical angles are congruent. Right, same side interior. So same side means it's on the same side of the transversal. So if I'm looking at these, I'll do them in different colors too. The black dots are on the same side of the transversal, and the blue dots are on the same side of the transversal. But the black and blue, if I were to pair them up, they are not on the same side. And then interior means it's on the inside of the parallel lines. So if this is my angle 1, the same side interior is going to be this angle down here. And if this is my angle to be the same side interior, this is going to be the other one. Now, if we think in terms of shifting the lines on top of each other, if I move that top line down to the bottom line, this one, the corresponding angle is now here, right? So these angles are not going to be congruent. They are next to each other on that line, so they are going to be supplementary. Okay. Alternate interior means they're on the opposite side of the transversal, and interior still means on the inside of the parallel lines. So if this is my angle, the alternate interior angle is going to be this one. And if this is my angle, the alternate interior would be down here. And now, again, if I think of that shifting the line on top of the other, this angle now becomes here. So now the relationship between them is that they're vertical, and vertical angles are congruent. So alternate interior angles are also congruent. A same side exterior, so same side of the transversal. This time we're on the outside of the parallel lines. So if I'm right here, the same side exterior would be down here. And then if I had a second one here, the same side exterior would be down here. Now again, with the idea of shifting one line on top of the other, either bringing it down or bringing it up, they would now be here. So then the relationship between these two pairs of angles are now adjacent, so they add to 180, meaning they are supplementary. And then we have alternate exterior. So alternate is on opposite sides of the transversal. And then exterior means on the outside of the parallel lines. Right? So if I go here, alternate exterior would be over here. And again, if I'm thinking shifting wise, that's where the two angles will now be. Now they are vertical, which means they are congruent. Okay? So alternate exterior angles are congruent. And let's work with some problems here. So solve for the angle measurements shown. So all right, this makes a straight line. So that makes these two angles, if we add them up, they're going to be equal to 180 because they're supplementary. So 5x plus 2x plus 5 equals 180. So I'll combine like terms. So 5x plus 2x is 7x. And then I want to solve for x. So I call it work from the outside in. So I've put an arrow on my x, so I need to see what's on the most outside. So yeah, 180 is on the most outside, furthest away from the x. Well, it's on the other side of the equal sign, so it's irrelevant for right now. So in terms of being in the way with my x, I have this being the furthest away. So I want to move it out of my way. To do that, I have to move it across the equal sign. And to keep things balanced, I have to do what I do to one side, I have to do to the other side. So I'm sure you're asking, well, what can I do to move it? So we're going to do the opposite of how it's attached to the x. So that 5 is attached to the x with a plus. So I have to do the opposite. So the opposite of plus is minus. So I'm going to subtract 5 from both sides. Because 5 minus 5 is 0. So I'm left with just 7x. And then 180 minus 5 is 175. And then x is close to being by itself. I just have a 7 attached to it now. And the operation that is holding that together is multiplication. So to undo it, we can divide. And then let's see what 175 divided by 7 is. I get 25 because 7 divided by 7 is just 1. So I have 1x equals, and then that equals 25. So it does say solve for the angle measures. So I now know what x is. So now I can find what these angle measures are. Because this first one here says it's 5 times x. Well, I just found what x is. So 5 times 25 is 125. And then this one I have 2 times 25 plus 5. That's 50 plus 5, which gives 55. And then these two angles, 125 and 55, should add to give 180. Okay? Now here, these angles add to give 90. Has this little square here telling us that's 90 degrees. So we can add all three of these up. So 9x minus 5 plus 4x plus 7x minus 5. Then that equals 90. So we'll combine some like terms. So anything that has an x, we will combine. So 9x plus 4x plus 7x is going to give me, see, 9 and 4 makes 13. 13 and 7 makes 20. So 20x. And then I also can combine my constant terms. So negative 5 minus 5. They're both negative, so it stays negative. So negative 10. And then all of that equals 90. And then we're back into a situation like we were in the problem before, where I need to isolate the x. So look at what's most outside, and then I can move things. So this negative 10 is on the most outside for me. So to do the opposite of minus 10, I'm going to add 10 to both sides. Right? Then I'm going to I'm going to divide by 20. I almost said subtract by 20. But the operation holding 20 to x is multiplication. And to undo multiplication, it's division. So 20 divided by 20 is 1. So I'm left with just x. And then 100 divided by 20 is 5. And now I can find all the angle measures. I can substitute in 5 for x in all of these. So 9 times 5 is 45. Minus 5 is 40. And then 4 times 5 is 20. And then 7 times 5 is 35. But then minus 5 is 30. And now all three of these should add to 90. 40 plus 20 plus 30. 40 and 20 make 60. 60 and 30 makes 90. All right. I can find all of these missing angle measures based off of those relationships. So right away, I can do my vertical angles. So I know that this one is 62, and vertical angles are across from each other and they're congruent. So angle 8 is also 62 degrees. Same thing here. Angle 11 is 62 degrees. And then same thing here. Angle 6 is 62 degrees. Okay. The next thing I would think of is that these two angles make a straight line. So 62 degrees plus the measure of angle 9 is 180. So I can subtract 62 on both sides. So that cancels out, and I'm left with the measure of angle 9. And then 180 minus 62 is 118. Sorry, angle 9 is 118. I can fill out a lot of information from here because 7 is a vertical angle. So it's also 118. Same thing here. Angle 14 plus 62 is 180. So I just did all that math. So that's also 118. Which means 12. It's a vertical angle to 14. So they are the same. Now we're going to use some different relationships for this next one, because it tells us that line 1 and line 2 are parallel. So I could probably use some other relationships here. So what I see is that I have 4 angles here. 1, 2, 3, 4. And I see that this angle here would correspond to this angle here. So that means they would have to be the same. So 118 would have to be the same as these two added up. So the measure of angle 2 plus 62. So I can subtract 62 on both sides. So the measure of angle 2 is 56. And then 2 is a vertical angle with angle 5. So that's also 56. All right, I need a fourth color here. Let's see, is pink? Oh, that's too close to red. Orange. That's kind of close to the red too, but I'll have to deal with it. Okay. And then what could we do from here? Oh, we could say that, hey, this angle here corresponds to this angle here. So that means this is 62 because those are congruent, which means angle 1, it's vertical to angle 4, is also 62. And then what I'm going to do is double check, because now, and I'll just highlight it actually. These 3 angles should add to 180. So 62, 62, and 56 should add to 180. And it does. So there we have it. We have all of those angles based off the relationship, whether they're supplementary or congruent. All right, and that is all for angles. If you have any questions, let me know.